The Agilent InfiniVision 7000B series oscilloscopes are engineered to give you the world's best signal visibility in 100 MHz to 1 GHz scopes. We do it by offering the biggest display in its class, the fastest waveform update rate, and insightful software packages. It all starts on the outside. With the 12.1-inch display, you get about 40% more viewing area than competitive scopes. Yet, your valuable bench space is still preserved with a 6.5-inch deep footprint. Our updated front panel gives you more dedicated controls for quicker access to the most commonly used features. On the inside, the engineering moves up a notch with Agilent's patented single IC MegaZoom technology that delivers 100,000 waveforms per second on screen with 8 megapoints of memory always optimized. Faster waveform update rates allow you to see more signal detail, maintain scope responsiveness to controls, and capture infrequent events more often. In this complex amplitude-modulated signal, we can see subtle waveform details, including an obvious signal anomaly. 256 levels of display intensity give a similar look to a traditional analog scope. To demonstrate the benefit of faster waveform update rates, let's take a look at a signal with an occasional glitch. Even though this glitch occurs very infrequently, about once every 30,000 trigger events, the InfiniVision scope captures it quickly, while competitive scopes will often miss it completely. Agilent Technologies invented the mixed signal oscilloscope in 1996, and our competitors have yet to match our capabilities. An MSO lets you capture and view up to 4 analog channels, along with 16 digital timing channels. You can see that we continue to observe our infrequent glitch. On this digital-to-analog converter signal, you can see that autoscale brings both analog and digital channels on screen, and you're able to trigger on any combination of the two. The MSO-based FPGA dynamic probe leads our list of software packages to help speed your debug and test tasks. It allows you to quickly import signal names from your design environment and move between banks of internal FPGA signals without recompiling your design for fast and efficient debug. When you want to know if a signal violates a known good condition, mask testing is the simplest way to find out. Using our glitch signal, let's create a pass-fail mask around this good waveform based on X and Y tolerances of the reference waveform using the scope's auto-mask feature. As we press Run, we can see that the scope captures the glitch very quickly and provides detailed statistics, including failure rate, or the rate of occurrence of this very infrequent glitch. Our hardware-accelerated technology means you can test waveforms to specified standards in seconds instead of hours. If you're still trying to count bits to debug your serial designs, Agilent's serial bus debug and test packages can save you significant time. In this measurement example, we're viewing a CAN serial bus signal with serial packets automatically decoded. The flashing red code near the end of this packet indicates an infrequent CAN error frame. Our industry-exclusive hardware-accelerated architecture means we capture errors other scopes miss. Enabling the serial lister display gives 2 views of the serial decoded data: a serial decoded trace that is time-correlated to the waveform, and list view of each field and packet. You can navigate through the serial data holding direct time alignment to captured waveforms by simply turning the selection knob to easily correlate to the source of this error frame. To search for specific information, simply press the dedicated front panel search key and enter the search criteria. Here, we find any remote or data frame with the ID of 07F. Use the scope's time navigation feature to automatically jump to the next or previous marked frame. Play, stop, and rewind front panel navigation keys allow waveform playback. If your signal of interest has bursts of activity followed by periods of dead time like pulsed laser research, radar, or packetized serial buses, Agilent's segmented memory software uses memory more efficiently. We capture and store only the signal activity without using memory for the dead time. On our CAN serial bus, we select segmented memory and capture 300 occurrences of our trigger. Review the captured data by simply turning the knob. Notice that each segment has accurate time tagging. We support a wide variety of serial bus standards with serial bus triggering and decode. In addition, we offer support for power applications and vector signal analysis. Offline viewing and analysis lets you view, analyze, and share captured data on your PC. With Agilent's InfiniVision 7000B series oscilloscopes, you'll see a display more representative of the actual signals under test and get uncompromised performance when acquiring any combination of analog, digital, or serial bus signals. Choose one for your next purchase. They're engineered for the world's best signal visibility.